so today I'm going to be teaching you the child division method to determine if a number is prime or composite. And what we're going to be doing today is determining if 631 is prime or composite. And first of all, let me tell you what prime and composite numbers are. So prime numbers are any counting numbers divisible by only 1 in itself, and composite numbers are any counting numbers that are not prime. So that's pretty obvious and easy to remember. So for 631, we're going to start dividing this by prime numbers, but we're going to skip 1 because any number divided by 1 is just going to be itself, and that's true for any number. So we're going to start by dividing this by 2, so I want you to get your calculators and do that with me. And so I got 315 and 5/10. And since this has 5/10 as the remainder, this does not work as a composite number, because for it to be a composite number, it has to have the other factors that it's also divisible by other than itself and 1 have to divide evenly with no remainder. So we're going to keep going, and we're going to go to 3 next. So do that with me. And 210 and 3/10 repeating. So that one doesn't work either. But now what we're going to do, instead of going to 4, we're going to skip 4 and go to 5. And the reason that we can do that is because if we had divided 2 evenly into 631, then that would have made 4 work too. So since we can automatically skip all the composite numbers, because the prime numbers that we're going to be using, you can build composite numbers out of. So we're going to skip to 5, and that's 126 and 2/10. And next we can skip 6 because that's built from 3 and it's also built from 2. So we're going to go to 7 next. And that's 90 and 1/10. Next we're going to be able to skip 8 and we're going to go to 9. And that's 70 and 1/10 repeating. And now we're going to go to 11. And that's 57 and 4/10. Next is 13. And that's going to be 48 and 5/10. And the next one is going to be 17. And that is 37 and 1/10. The next one is 19. And that's 33 and 2/10. And the next one is going to be 23. And that one comes out to be 27 and 4/10. And as you can see, as these numbers on the left side get bigger, the numbers on the right side get smaller. And that's going to mean something when we get towards the end, and I'll explain that once we get there. But for now, I'm going to keep going. And if any of these numbers had come out with no remainder and they would have divided evenly, then this number would be composite. But since we haven't found that yet, then we're going to keep going. And it still has the potential to be composite, but it could also still be prime. So we're going to divide it by 29, which is the next prime number. And that comes out to be 21 and 8/10. And so I can stop here because 21, if 21 had worked and divided into 631 evenly, then it would have already shown up in the list. So I can stop here and say that the number is prime because it does not divide evenly into any numbers bigger than this now, because they would have already shown up in the list so far. So that's the child division method, and I hope that you learned something.